Yeah, this works. So good morning, everyone. I'm Yanjun from Institute of Software, Chinese Academy of Sciences. And today I'm very glad to share with you our journey with openEuler for RISC-V servers. So let's start with a brief introduction about openEuler. Sorry. Is that okay? So, excuse me, can I use this? I don't, it doesn't work? It works? Yeah, great, thank you. So let's start with a brief introduction to openEuler RISC-V. openEuler is a RPM-based Linux distribution, but it's just not just another CentOS. It's mainly deployed on servers. And here's the website. Since it's open source in 2019, it has mainly targeted on server deployments. It has a large and active community with a significant number of users, organizations, SIGs, and contributors. For the RISC-V architecture, openEuler has made remarkable progress. For example, in terms of package support, we have seen a steady increase over years. The openEuler RISC-V has different release versions. The LTS version, released every 2 years and maintained for 4 years, provides long-term stability for users. In the innovation version, released every 6 months and maintained for 6 months, brings the latest features and improvements. It's just like what Ubuntu has did. As an example, openEuler, we have one standard code base, one shared code base, one build system, and one quality assurance standard, and results in one ISO images. And we use Euler Maker to support for RISC-V architecture enabled. And you can see that Euler Maker can make x86 and ARM and RISC-V all together. It's not a branch. It's all the codes are in the main line. And we have dual circulation to accelerate iteration of RISC-V versions. We have maintained a dual infrastructure for the openEuler package development. And we also have unified quality assurance standard for multi-architecture. This is, you can see that this is the test suits and the cases number. And we have unified ISO release for QMU for some real hardwares. And now we have supported a lot of server software stacks like virtualization, mail server, database, container, web, and hotfix services. And we also have more than 10 DVB support. And maybe you can, when you see the demos outside, and many of them are pre-installed with openEuler. So, however, the current RISC-V ecosystem faces several challenges. We have analyzed in details about these challenges, and we concluded with 4 problems. Problem number 1 is slow upstream acceptance. Upstream acceptance of core software like Linux kernel lags behind the needs of production. The Linux configuration files for different RISC-V support hardware has different update frequencies, some of which haven't been updated for over years. This causes maintenance fragmentation, making it difficult to keep up with the latest developments and ensuring compatibility across different hardwares. Second problem is ISA and SPECs still under development, so it's very hard to the ratification of ISR SPEC is relatively slow compared to the vendor's product. The vendor's product marketing efforts. Standard like RVA 2022 and RVA 23 and the server-related specifications are still under development. This lack of stable standards can lead to the compatibility issue and hinders the widespread deployment of RISC-V technology. Third, the software and hardware ecosystem is still incomplete. There is insufficient software support for RISC-V in upstream repositories. We also lack multi-hardware test environments like CI, CD, and the Docker images, and the comprehensive test suites. This incomplete ecosystem limits the development and deployment of RISC-V-based systems. So, but the good news is RISC-V is on the verge of entering a golden area of high-performance computing. RISC-V Server Platform SPEC draft is becoming more stable, and openEuler 24.3 LTS can serve as an excellent choice for the RISC-V fundamental software baseline. This is the best time to address these challenges. So I will show our solutions to tackle the fragmentation. To tackle these issues, we have proposed one mission and 4 plans. So our fundamental vision is to advance the openEuler RISC-V and its ecosystem development in line with the upstream standards, such as the RISC-V Server Platform SPECs, and also with some other specs like boot runtime and RVA 23 profile. The first of our plans is the RVA standards evolution plan. This plan guides version iteration and updates by adhering to RISC-V profiles. We keep close eye on key upstream standards like RVA 23, server platforms, boot, and runtime services, vector, and hypervisor specs. By following these standards, we ensure that openEuler RISC-V remains up to date and compatible with the latest RISC-V developments. The second is the RVCA strategy infrastructure plan, aims to provide RISC-V CI gatekeeping support for openEuler, promoting community-native development. We face the challenge of insufficient computing power, but we have found a solution in the distributed compilation method. And this plan helps us to ensure the quality of the software development in the openEuler RISC-V community. The third is the RVCK, a kernel homogeneity plan. That means we use the common kernel for the RISC-V community. And you know that kernel fragmentation also causes hardware diversity. We encourage vendors to develop along a unified kernel version, which is the name RISC-V common kernel comes from. And this brings several advantages, including community native support for the kernel, and also the ability to backport upstream new features. And we extended the kernel to like 300 packages. It's up kernel like glibc and other packages. So we use a common version for all these support to the hardware vendors. By unifying the kernel and the other packages baseline, we benefit both the upstream and downstream ecosystems. The last is Rava test completion. So I know anybody from Linaro will be familiar with Rava. And we have Rava test completion plan is about to establishing a CTS standards compatible testing system that implementing automated tests. This allows community-native verification of hardware support. We use various testing tools and environments like Lava test, openQA test, and RISC-V QML to ensure the quality and the compatibility of RISC-V hardware. So in conclusion, we have moved from fragmented RISC-V ecosystem to a path of defragmentation and diversification. Through our efforts to openEuler RISC-V development and ecosystem plans, we are working together to build a more prosperous RISC-V software ecosystem. So thank you all for your attention. If you have any questions, please feel free to ask. And we also have a poster over there corner. Thank you very much.